Good evening. Welcome to the QCIS channel. Where on this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and apologize for this late video. I normally do these videos on Thursday, but I had some other projects to work on, such as studying for the FE examination. But today or this evening, I'm going to talk about a concept called a matrix. Now, I'm not talking about the matrix that was on in 1999, where you have the red pill and the blue pill. I'm actually talking about a rectangular set of numbers or symbols that's used in mathematics. If any of you are familiar with linear algebra, you will find matrices, augmented matrices, or you'll find cofactors. Matrices can also represent a system of equations. You can even represent an algorithm, ones and zeros, computer language. And that's what you get with matrices. Now, let me share my screen and let's have a definition of what a matrix really is. So, when we deal with a matrix, basically we're dealing with a rectangular array or table of numbers, symbols, or expressions, which, and with elements, there are lots of elements. Now, matrices or matrix can be 2 by 2, 3 by 3, or it can go up to as large as you want it. And in a matrix, the numbers are arranged in rows and columns to represent a mathematical object or property of such an object. Now, if you look at this matrix right here, this is an example of a matrix. Now, what we have here, we have 3 columns and 2 rows. So we always go with the rows first. So this is what we would call a 2 by 3 matrix. You have 2 rows and you have 3 columns. Now, there are different types of matrices. Matrices will work well if you know how to do the operations. And if you're going to take the FE exam, you're going to deal with matrices in some form or another. Again, this is a matrix as well. Row vector, column vector, a square vector. That's what a matrix is. Now, what I'm going to show you is operations with matrices. Operations with matrices. Now, what should you learn? Well, I've already given you a definition of what a matrix is. So what you're going to learn from this presentation, you're going to decide whether you have 2 matrices that are equal. You're going to be able to add and subtract matrices and multiply matrices by scalars. It'll multiply 2 matrices. That's where we get the product from. And you're going to use matrix operations to model and solve real life problems. Now, also, when we deal with matrices, you have eigenvalues and eigenvectors. Now we deal with the equality of matrices. So this section of the presentation is going to introduce some fundamentals of matrix theory, the standard mathematical convention to represent matrices in one of the following ways. Now, the representation of a matrix. Well, matrix can be denoted by an uppercase letter such as A, B, and C. A matrix can be donated by a representative element enclosed in brackets. That's basically what you see. And a matrix can be donated by a rectangular array of numbers, such as what you have here. This is your matrix. That's what it looks like. Two matrices are equal when they have the same dimension, m times n, and all of their corresponding entries are equal. Now, solving for A11, A12, A21, and A22 in the following matrix equation. Now, this is something, if you don't understand matrices, you can copy this information. Now, because two matrices are equal only when their corresponding entries are equal, you can conclude that A11 or A11 equals 2. This is A11 right here, 2. A12 equals -1. This number represents A12. Now, I'm going to give you my belief on the subscripts of these variables in a minute. A21 equals -3. A22 equals 0. Before I go on, let me tell you what these subscripts really mean. Now, when I have A11, what I am telling you is A11 is column 1, row 1. A21 is column, is actually, let me correct this. A11 is row 1, column 1. A21 is row 2, column 1. Now, when I have A12 is row 1, column 2. A22 is row 2, column 2. Now, where did I get all of that information from? Okay, here's the answer. This row right here, this A row, this is row 1. This is where you get the A1 from. This is row 2. When we go down vertically, this is column 1. And this is column 2. So we conclude that A11 equals 2, A12 equals -1, A21 equals -3, A22 equals 0. That means the dimensions are the same. We have 4 elements in each matrix. Now, this is what you need to understand as well. Dimensions. Well, be sure you see that for two matrices to be equal, they must have the same dimension, just as I have spoken before, and their corresponding entries must be equal. And here's what I'm talking about. You have 4 items here, and you have 4 items here. This is what we call a 2 by 2. So a 2 by 2, that's your dimension, and a 2 by 2. Here, you have what we call a 2 by 3. But a 2 by 3, because of the dimension, these two matrices are not equal because the dimensions aren't equal. You have a 2 by 3 matrix and you have a 2 by 2 matrix. Again, this is basic information. Now we get into matrix addition and scalar multiplication. And you can solve a number of these matrices on a calculator as well. Okay, you can add two matrices of the same dimension by adding their corresponding entries. So the definition of matrix addition, if A equals A ij and B equals B ij, and they're matrices of dimension m times m, that's Mike times November, or m times n, then their sum is the m times n matrix by giving this expression: a plus b equals a ij plus b ij. The sum of two matrices of different dimensions is undefined. So let's get into the addition. So when you add matrices of the same dimension, what you're doing here, you're adding, normally it's A plus B. So this would be matrix A and this would be matrix B. So matrix A, you're going to have A11 plus B11. So when you add these two numbers up, -1 plus 1 gives you 0. You have it right here. 2 plus 3 is 5. 0 minus 1 is -1. And of course, 1 plus 2 equals 3. And the same would apply for this matrix as well. Now, this is a single matrix, but the same thing would apply. See, the dimensions are the same. Now, for this second one, it's undefined. Why? Because you have a 2 by 3. And correction, going back to this last one here, this is what we call a 3 by 2. 3 rows, 2 columns. It's a 3 by 2. As you know, the dimensions are unequal. So right here, you have a 2 by 3 matrix and a 2 by 2 matrix. Since their dimensions are different, the rule applies. This matrix is undefined, so you cannot do addition with this matrix. Now, in operations with matrices, numbers are usually referred to as scalars. Now, you've taken linear algebra, there's vectors, and there's scalars. Now, what I'm going to tell you is, during this presentation, scalars will always be real numbers. So you can multiply a matrix A by a scalar C by multiplying each entry in A by C. So if A equals lowercase aij is an m times n matrix, and C is a scalar, then the scalar multiple of A by C is the m times n matrix given by C times A. Now, for the following matrix, find 3A. Well, you're already given A, so what you're going to do, you're going to take your 3. It's almost like your coefficient. Well, you're going to multiply 3 times this whole matrix. So we're going to come up with these numbers. And also with matrices, you can do determinants as well. Did you see what they did here? 3 times 2. This is what you call a 3 by 3 matrix. Everything has been worked out. It's how all the numbers. And if a number of you are having trouble with matrices, to do them by hand, This presentation will teach you everything you need to know. Now, the properties of matrix addition and scalar multiplication are similar to those of addition and multiplication of real numbers. So one important property of addition of real numbers is that the number 0 is an additive identity. And that is C plus 0 equals C for any real number. So for matrices, a similar property holds. And we're going to get into that in a moment. Now for matrices, a similar property holds. That is, if A is an M times N matrix and O is the M times N zero matrix consisting entirely of zeros, then A plus 0 equals A. So in other words, 0 is the additive identity for all the set, for the set of all M times N matrices. For example, the following matrices are the additive identities for all of the 2 by 3 and 2 by 2 matrices. This is a 2 by 3 matrix. This is a 2 by 2. This is a 2 by 3 zero matrix, and this is a 2 by 2 zero matrix. Has it right here for you. Now we also get into some properties that involve other forms of mathematics, particularly algebra. This is the property of matrix addition and scalar multiplication. So basically you let A, B, and C be M times N matrices and let C and D be scalars. Now, you have heard of the commutative property. And what we mean by the commutative property is if I have two numbers and I switch them around, I should get the same number. Let me give you an example. So a commutative property would be if I add 2 plus 4, I get 6. But then if I switch numbers around and have 4 plus 2, which is commutative, I get 6. Now, the associative property of addition is very, very similar. When I have A plus B plus C. Now, you are supposed to get the same number, and it depends on where you start the operation. Now, this is for addition now. Remember, this is for addition. Just like the first one was the commutative property of matrix addition. Addition, you're always going to get the same number if it's commutative. Well, the associative property, you're going to get the same number as well. Like if I have 1 plus 2 plus 3, and my parenthesis is on 2 plus 3, I'm going to start with that operation first. I get 5, and I get 1, and that equals 6. Now, if I move the parenthesis over to A plus B, and I still have 1 plus 2 plus 3, well, 1 plus 2 is going to give me 3, and then I'm going to add another 3, and I get 6. So just as with the commutative property of addition, the associative property of addition works basically the same way, except it's just the position on where I start the operation of addition. That's all. Now, something else you need to know as well, works the same way with multiplication. The associative property of multiplication. So 2 times 4 times 3 is going to give me 24. 2 times 4 times 3. So if I start the parenthesis at lowercase cd, I'm going to come out with 2 times 4, which is 8 times 3. Well, if I have 2 times 4 times 3, well, I'm going to start it out 4 times 3 at the second position at lowercase d, uppercase a times c, which your c is your scalar value. Your scalar value, I'm going to get the same answer. That's what you get. Now, when you have an identity, what do I mean by an identity? Well, you have 2 identities. See, in addition and multiplication, when you multiply any number by 1, you're going to get that same number. In multiplication, that's the scalar identity. Well, the additive identity is the same thing. If I add anything by 0, I'm going to get that same number. So a plus 0 equals a. Well, you also have the distributive property. Now, you see a lot of these properties in algebra, and these are very basic, where I have c times a plus b in parentheses. Well, when I use the distributive property, what am I doing? I'm distributing c into the operation of addition. This is where I get lowercase c times a plus lowercase c times b. Now, it can also go the other way. C plus D times A. Well, I'm getting A to be distributed into the operation in the parentheses C plus D. So I'm distributing A into that operation of addition. This is where I get lowercase c times uppercase A plus lowercase d times uppercase A. And when you're doing algebra or even trigonometry, it's very important that you understand these properties. Now, does this work with subtraction and division? No. Also doesn't work with negative numbers either. Not all the time. Sometimes. All right. Using the distributive property. It's just like doing regular operations. You have your 3 and you have your matrix out here. And this is what everything looks like when you use the distributive property. In other words, you'll come up with a solution right here. This is how you get all of your solutions. Now, you can also do this on a calculator, but I tell you this, you should always learn it by hand before you put it on the calculator first so you can understand the concept. A number of us depend a lot on the calculator, but when you understand it by hand, you're not going to make any mistakes with utilizing the calculator. The calculator just help you minimize the error, but this is how you use the distributive property when it comes to matrices. Okay, real numbers, solve for x. Well, x plus a equals b. So how do I find x? Well, just like algebra, you want to subtract a from both sides. And then solve for x, x equals b minus a. N times n for matrices, solve for x. It's the same way. Solve for x in the equation. 3x plus a equals b, where you have a and b. So what are you going to have to do? You really want to solve for x. Well, first, you're going to move a to the other side where b is. So you're going to subtract both sides by a, and then isolate x. This is a regular formula, in which I will get into some algebra in some of these videos as well. Once you subtract both sides by A, then you're going to divide both sides by 3. And this is how you get, this is how you solve, the same thing for a matrix equation. Same thing. Now here's the solution. Now they use 1/3, but here's what you do. To find X, you already have matrix A and matrix B. You divide everything by 3. Okay, and you look at the signs. And then once you do all the subtraction, then you're going to do your division. Divide everything by 3. Or multiply it by 1/3. And that gives you this solution. It's basic algebra. Now we're going into matrix multiplication. Another basic matrix operation is matrix multiplication. And you'll see later that this definition of the product of two matrices has many practical applications. So if A equals lowercase a I j and is a m times n matrix, and B equals lowercase b I j is an n times p matrix, then the product AB is an lowercase m times lowercase p matrix given by AB equals lowercase ci and j. And here's the definition right here. On to slide number 22. The definition of matrix multiplication indicates a row by column multiplication, where the entry in the ith row in the jth column of the product AB is obtained by multiplying the entries in the ith row A by the corresponding entries in the jth column of B, and then adding the results. Look at the next slide so you can multiply these matrices, see how they're multiplied. And here's the general pattern of how the multiplication works. Find the product AB using A. Well, and then you also have DB. Well, the solution, first note that the product is defined because the number of columns of A is equal to the number of columns or number of rows of B. Moreover, the product AB has a dimension of 3 by 2. This is a 3 by 2 matrix. Find entries of each product, multiply each row of A by each column of B. And here's how you do it. A times B. So you can do it. 3 by 2 times a 2 by 2 matrix. It's just following the rules. It's algebra. I actually like matrices as well. Use them to solve a lot of systems of equations. Again, The general pattern for matrix multiplication is as follows. Again, you have your properties of matrix multiplication. So again, just like addition, you let A, B, and C be matrices, and let C be a scalar, and you utilize your associative property of matrix multiplication. So you have A times B times C equals A times B times C. You also have your what we call your left distributive property, where just from the left, it's a distributive property. A times B plus C, just like addition. You're just distributing A into the operation. And from the right, you're doing, you're putting C in front of everything. I prefer doing everything left to right. And then also you have your associative property of scalar multiplication. I mean, once you understand the rules and watching this PowerPoint, you'll be able to do addition and multiplication. And I'm also finding one for division and subtraction of matrices as well. And I'm also getting the eigenvalues, eigenvectors, determinants, transposing matrices. And this will help you in linear algebra if you're taking that course. All right, definition of an identity matrix. Again, the n times n matrix that consists of ones on its main diagonal and zeros elsewhere is called the identity matrix of dimension n times n, and is donated by, and here's what you see up here. Now, when we're doing what we call a row reduction, called the row reduction echelon form, known as RREF, you're going to have something called the leading ones. Now, this is what's used in computer language, and this is what you call a leading one. And you use the what we call the Gaussian and Jordan rule for eliminating numbers where you're coming up with ones and zeros. You want a lot of your numbers. This is your triangular part. This is what you do when you are using systems of equations. Now note that the identity matrix must be square. When the dimension is understood to be n by n, you donate I subscript n simply by I. Finally, if A is a n by n matrix, then the identity matrix has the property AI subscript n equals A, or A or I subscript n equals A. And if you really want to know what property that is, that's called the commutative property. And here's what everything looks like. Get 3 times 1, everything, what it looks like. But what you've had was an overview on matrices. Again, I'm gonna get some information on the subtraction and division of matrices, talk about some determinants, talk about Kramer's rule. Because again, if you are in the computer field, a matrix is an array of items. You look at it as an algorithm. Those computer language is always in ones and zeros. You can also take the system of equations. You can utilize a matrix. Now, Kramer's rule, it's not the Gaussian Jordan elimination method where you're finding ones and zeros. You're going to have to take a matrix and divide it by the determining. But overall, it's very important that you understand matrices. Now, of course, in a calculator, particularly if you have a Casio or if you have a TI, you can do a matrix up to a 3 by 3. But when it comes to 4 by 4, that's a different ball of wax. In fact, when you're doing anything over a 3 by 3, you're going to have to convert a number of bigger matrices if you can do it into 3 by 3. And you can use the diagonal method. And the diagonal method is a very good method. I actually had done some matrices, and I will bring those up. But it's very important that you understand how mathematics works, especially if you want to be an engineer, a scientist, a mathematician. I enjoy mathematics. Mathematics is a true science. Gives you the answer right there. You just have to understand the methods. And what I gave you in tonight's presentation is methods of, and I'm just going to call this part 1, dealing with multiplication and addition, matrix operations. But once you know the basics, you'll be able to get into the more complex arena of solving matrix operations with 4 by 4, 5 by 5, and even 6 by 6 matrices. But anyway, thank you all for listening and viewing this content on vector or matrix operations for addition and multiplication. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some social and political content, check out my main channel, the 411 Talk Zone radio show. And here's where you can find me. On the 411 Talk Zone radio show, you can find me on YouTube, X, formerly Twitter, Truth Social, and Rumble. For the QCIS channel, you can also find me on YouTube. You can also find me on X, formerly Twitter, and you can find me on LinkedIn. Once again, thank you for viewing this content on matrix operations for addition and multiplication from the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. You all have a wonderful and gracious evening.